Welcome back everyone. We're going to have a look at the final model planning exercise that I gave you. Just to remind you again what these are for. These are to just test that you can visualise in your mind how you would make these parts if you were going to use a 3D modelling program. Remember, the one that we use in school is called Inventor, but there are lots of other ones out there too. And some of you might have been using Onshape, which is an online version of a 3D modelling program. What I asked you to do was have a look at this drawing here, which is a representation of a mini fire extinguisher. The extinguisher is made up of 4 parts. There's the red main body, the gold cap or valve as I think I called it, there's a little silver connecting pipe, and then there is the, I don't know what you would call it, it's the nozzle I suppose at the front, the black part. So the main body, the valve, the connecting pipe and the nozzle. What I asked you to do was have a look at this drawing, which is in front of you on the screen here, and I know the resolution is not that great, but you've got a good copy that you can access and see a bit more clearly. But this is just to give you an idea of all the individual parts. What we're going to look at is first of all the black nozzle. We'll then look at the red body, the silver connecting pipe, and finally the gold valve at the top. Once I've shown you the model plan itself, I'm going to have a go at explaining using Inventor how the model plan once again connects to the 3D modelling itself. I hope that's all clear. So let's get started. I'm going to try and zoom in here, but my laptop's going a little bit slow today. We'll see how we get on. First is the nozzle part of it. How I decided to do that was by using the revolve command. Now I could have done it with loft, but I decided it would be just as easy to do it as a revolve. My first step was to sketch the 2D profile as it's shown, and I'm going to try and not move the mouse too much, but sometimes I have to move it just to show you what I'm talking about. So we're looking at step 1, which is up the top of the screen here. I've indicated where my axis is by use of that centre line. I've shown the height that I want the nozzle to be, or the length in real life. And I've got 2 dimensions, one at either end, one that says 40 and the other one that says 15. And the reason for those is that the nozzle has got a diameter at the larger end of 80 and at the smaller end it's 15. That's me got the sketch in place. Step 2 is to then revolve that profile around the axis for 360 degrees. And it's important to say it's a full turn or 360 degrees, because if you don't say that, then we won't end up with the shape that we're looking for. In my model plan, I've just made that little point that I could have done step 1 and 2 by doing lofting. I could have sketched a 2D profile of an 80mm circle, offset a plane by 200, and then drawn a concentric 2D profile of a 30mm diameter circle, and then lofted between the 2 of them. Step number 3, I'm now going to hollow it out, or I'm going to use the shell command. And the wall thickness is 3mm, and I worked that out by looking at the inside diameter and the outside diameter. In this case I'm only going to remove the larger end of it, and the reason for that is that if I was to shell and remove this end and that end, the size of the hole at this end would be bigger than what I require. So in this case I've only taken off the face at this end, which means I need to create the hole for the silver nozzle to go into. So I do that through step 4 and step 5, which is on the centre of this end. I create a 2D profile with a diameter of 20, and I then use extrusion by subtraction to cut through and make the hole. Nice and simple. Going to have a look now at Inventor and see how it was done on that. Scroll down to my page, and then I've got the profile just like it was shown on the model plan itself. 40mm at the top, 15mm at the bottom, and a height of 200. That's my sketch all set up, and I'm going to revolve around this profile here. If I click finish sketch, it will now complete the shape for me. If I move my end apart marker up just after that point, we now have a solid, which is what was created after the revolve. I'm going to bring my end of part marker down just after the shell, and we can now see that the end of it has been opened up, but there's still no opening in the small end of it. To do that, as I explained, it was an extrusion with a 20mm diameter hole, and then extrusion by subtraction. And there we can see it there. Nice, simple, straightforward. And I also applied an appearance to it. Pretty straightforward, that one there. Once again, I could have done it through lofting. I could also have sketched the profile, which would have taken into account the wall thickness before I revolved it. So like most of these tasks, there's more than one way to do it. Let's go back to my model plan, and now I'm going to look at itself. At risk of repeating myself, I could have done this a different way. I've decided to do it by a mixture of extrusion and lofting, and once again I could have done it by revolve. However, I chose to do extrusion and loft and then extrusion. Step 1, sketch a 2D profile of a circle with a 100mm diameter and then extrude that by 300mm. My little sketch, as you can see, shows a 100mm circle and it shows the 300mm direction of the extrusion. Step number 2, I've said that on the end of that extrusion I'm going to create a plane which is 100mm from the end of it, so I'm creating an offset plane from the end of that extrusion, and on that plane I'm going to create a sketch, a 2D profile with a circle of diameter 50. Now what I should have said here, and I've omitted it just to show that we all make mistakes, I should have said that that circle has to be concentric with the larger cylinder so that it ends up in the centre and we have a resulting symmetrical shape. What I then said, once we had put that 2D profile, step number 4 was to loft between the end of the 100mm diameter and the 50mm diameter circle that we just did, and it would create that tapered effect. So it tapers down from 100mm down to 50. Step number 5, from the 50mm cylindrical shape I'm going to extrude a further 30mm to give me effectively the neck of the bottle. That's that part here. That was that additional 30, and I got that size from my orthographic drawing. Now steps 6 and 7 are a little bit out of sync, and I'll try and explain that to you. What I'm going to do next is create the fillet on the bottom of the bottle. Now remember, a fillet is a rounding off of a sharp corner with a particular radius. In this case it's 10mm. I'm going to do that before I do the shell command, and I've got the shell command here, and in this case I would only be removing that face. Fillet and then shell. What I'm going to do on Inventor, I'm going to try and show you the difference between those two, so hopefully that will work out. Take myself to Inventor and I'm going to go to the body. So here is the body of the fire extinguisher here, and I'll use my end of part marker once again just to explain how I made it. I began with a 100mm 2D profile here, and I extruded it by the length of the bottle, 300mm. At the end of that I then put on a work plane, which you can just hopefully see on the screen becoming visible. And on that work plane I then created a circle which allowed me to sketch that profile and then loft this part from here to here. Finally, I extruded that 50mm diameter circle a further 30mm to give me the neck of the bottle. Now it's important, as I said, that we do the fillet and then the shell in a particular order. And I'm going to try and show you what this is. So if you bear with me, I'm going to zoom in a little bit on the bottom of the bottle, and I'm going to change my visual style to wireframe with hidden edges. Now right now the bottle is solid. What I'm going to do is fillet it, and that puts the curve onto the bottle, and then I'm going to shell, and you can now see the inside shape of the bottle follows smoothly the outside shape. So what happens if I do that in a different order? Well, I'm going to take my shell here and I'm going to move it up to there, and you can now see what's happened. The inside of the bottle is coming round and it's hitting the fillet. Now in real life that wouldn't work because it's almost cutting through the outside. So it's important that we think about shelling and filleting and chamfering, which is similar to filleting, that we think about the order that we do those. We have to do the fillet or the chamfer first and then do the shell. So that's a proper way to do that. Take it back to my shaded view and hit home. And there is my finished bottle. So hopefully that's made sense. Extrusion, followed by a loft, followed by an extrusion, followed by a fillet, and finally a shell with the removal of only one end to give me the opening in the bottom. Let's move on to the connecting pipe. As before, I'm going to attempt to zoom in. Shows what we're doing here. Right. Step number 1, I sketched the profile shown, which was a 20mm diameter circle and the 16mm diameter one concentrically even inside it. Then I've said, step number 2, at right angles to this, I created a plane, and on that plane I sketched the path profile. So you can just see our little plane here. And there I've got my path of 42mm in that direction, and then changing direction at this angle and going a further 52. I've then said I'm going to use the extrusion along a path and create the final shape. In Inventor and in other 3D modelling programs, it sometimes doesn't use the phrase extrusion along a path. It will say something like sweep. We have to be careful to use the correct term though, and the correct term is extrusion along a path. And I've got a note at the bottom that says here I could have made that as a solid and then shelled it with the correct wall thickness. So instead of doing these double circles up here, I could simply have done a 20mm diameter circle, done the extrusion along a path, and then shelled it at both ends with a wall thickness of 2mm, which would give me a 16mm inside diameter. So once again, more than one way to do it. What does that look like on Inventor? Well, that's a nice simple one on Inventor. And just to show you what it looks like, I'll click on Edit Feature and that will open up some of the details. And with a bit of look, you can see the numbers here. We have our two circles, 16mm inside and 20mm outside diameter. Our initial path of 42mm, then switching and going at 52mm in this direction. And as I said, we could have done this as a complete solid and then shelled it at either end. But doing the correct profile to begin with probably speeds things up a little bit. Which brings us to the final part, which is what I call the valve, and that's the gold piece. I could have done it using revolve. I could have drawn half the profile and revolved it. I could have did it that way. But I've decided in this case I'm going to use extrusion. I looked at the bottom diameter, which is 46mm, and I said to sketch that 2D profile and then extrude it up by 20. Step number 2, on top of that new shape, sketch a 2D profile of diameter 50. Once again, I should have said it was concentric with the one below it, just to make sure it lines up with it, and then extrude that by 40. That's me got the basic shape. Now I have to create the hole through the centre of it, and to just remind you of that, I'm going to take you to the drawing, and the part we're looking at is this part here. So it's got a lot of little holes and things in it. We've now made the basic shape. We're going to create that hole going through there, which is 50mm deep. And what I said for this part was, on the bottom face, in the centre, sketch a 2D profile of circle diameter 30, and then step number 4, extrude that circle by subtraction 50mm into the part to make the hole, because it told me on the orthographic drawing that it goes 50mm in that direction. Step number 5 was where you had to really have a good idea how to use planes, because what we have to do is create this hole in the side. Once again, more than one way to do this. What I did in this instance was I created a plane which was on the edge of the shape, just touching the edge, at a tangent to it. Step number 6, on that plane, I sketched a 2D profile of the circle and I extruded it by subtraction 15mm in the way, and that made the hole that joined up with the 30mm hole that was going up the way. And the final part I had to do was a little note for step 7, fill at the edge with a radius of 2mm. What we need to be careful with these is that we don't list every single step that we're doing in the sketch mode. You'll notice that my sketches have got all of the information on them that's required. The writing tends to be, for the most part, about the 2D sketch being then turned into something else with the 3D command. For example, on here we've got on top of the new shape, create the sketch as shown, and then here's our 3D command, extrude by 40mm. The sketches should be done as sketches, and the 3D commands are then part of the description. That's what we're aiming for when it comes to this. Let's go to Inventor for our last time. Over here we're looking at the valve, and here we have using the end apart marker. I'll take this up. So our first extrusion was that bottom part. Remember what I said was that I created a circle on top of this and then extruded that up the way, which gives us that. I'll turn it round and show what happens next. We were going to create the hole through the base. Take my end apart marker down, and there's a hole created there, 30mm diameter, going up into the shape by 50. Now if I bring that down and just hover over the work plane, you can see that work plane that I was talking about. You just see it going visible and invisible. And on that work plane, I sketched the diameter circle that I was looking for, which is shown there, 20mm diameter. We'll just zoom in a little bit for you. There we are, 20mm diameter, and you can just see that straight line at the top indicating where that plane is. And that was then extrusion by subtraction into the shape to complete it. The last thing I have to do is, if you look at the top edge, it's a little bit sharp looking there, so what we said, to finish things off, we'll put a fillet on and that will smooth things around a little bit. Here's what our assembled fire extinguisher looks like in all its glory. All the parts constrained together, and they've all been given appearances to make them look realistic. I know that was quite long and there was a lot of switching between screens, but hopefully you've got the idea. When it comes to model planning, our plans have to be a combination of a sketch, and the sketches don't have to be brilliant, but they have to explain what it is that we're trying to do with the 3D command. So just keep that in mind. Anything that you're doing in sketch mode, you sketch it on your model plan, and once you finish sketch mode, that's when you have to talk about the 3D command that you're going to use and what you're going to do with that command. And that means whether it's extrusion by addition, extrusion by subtraction, complete revolutions, what dimension you're going to 3D command by, whether you're going to extrude by 100mm or 50mm, and all the other parts that come with it. Try and keep that in mind when you're doing your model plans, and hopefully that will allow you to pick up as many marks as possible. I hope that's made sense to you, and it's your job now to check your model plan, see how it looks compared with mine, and also if you've had a chance to use a 3D modelling program, either Inventor or one of the other ones, to see if you could make the 4 individual parts and then constrain them together. Thanks for watching.